Statistics 1 exam grades on the final exam are normally distributed with a mean of 75, a standard deviation of 13. If samples of 100 students are selected at random from the population, what is the mean of the sample means? What is the standard error, i.e. standard deviation of the sample means? Okay, so the important phrase here in this problem is this idea of sample means. So we're talking about x bar here, right? And we're asking what's the mean of x bar? So what's the expected value of x bar? And what is the standard error or standard deviation of the sample mean? So what we're trying to find is this. We would like to know what is the mean for x bar and the standard deviation for x bar. These are the two things we're trying to find. Okay, so we actually have a nice theorem, the essential limit theorem, that teaches us about these concepts. And that theorem has a simple statement about these two quantities. It tells us that the mean for x bar is simply equal to the mean for x. So in other words, whatever they gave you for the phenomena that you're dealing with, whatever they gave you as the mean, that remains the same. So here they tell us that Stats 1 exam grades on the final exam are normally distributed with a mean of 75. So we know that the mean is 75. So we're done. We have that finished. There's nothing more to do. We don't have to do anything special to solve this part of the problem. For the other part, the standard deviation of x bar, or the standard error for x bar, that's going to be equal to the original standard deviation for x divided by the square root of n. So in that case, we have this quantity given to us. It tells us the standard deviation is 13, so we'll put 13 there. And then they say to divide by the square root of n. So it says here, if samples of 100 students are selected, then we're talking about the sample means in that scenario. So that means that n for us would be 100, so the square root of 100. So of course, that'll be 13 divided by 10. The square root of 100 is 10. And then that'll end up being 1.3 if you work that out. So we end up having the idea that the mean remains the same for x bar. In other words, x bar's mean is the same as the original data set's mean. And then the standard deviation for x bar is much reduced. It's reduced by a factor of the square root of n. So the square root of 100 in this case gives you 10, and then 13 divided by 10, we get the result 1.3. So just remember that the mean of the sample means is the same. The standard error or standard deviation of the sample means is the standard deviation divided by the square root of n. Just the terminology issue I want to mention before I leave this problem, and that is that standard error and standard deviation of the sample means, they can be used interchangeably. Standard error is used when you talk about the standard deviation for sample means, because if you're talking about the original data set, the standard deviation represents like the typical deviation of the variable. So in this case, exam grades, they vary because students do differently on the exam. Some do well, some do poor, some do average, etc. So there's some deviation present. That isn't an error, right? If somebody's grade is different from somebody else's, there's no mistake there. It's just a natural phenomenon, right? If you're talking about a sample mean, though, its role is to predict the population mean. We have a sample mean x bar so that we can predict ultimately the population mean mu. That's our goal. And so when x bar is different from its mean, and remember its mean is the population mean, when x bar is different from it, it is a deviation from the mean, that's true, but you wouldn't necessarily call it standard deviation. You might call it a standard error, because standard error would mean that it's your typical error. And it's an error when the x bar is not the same as the mean, because its role is to estimate the mean. So if it's different from the population mean, we could actually consider that an error. So it's kind of an interesting thing about the notation. If you're wondering why they call it the standard error of the sample means, it's because when x bar varies from its mean, which is mu, it's actually missing its target. It's supposed to be predicting the mean. And so when it's not the same as the mean, it's not just a deviation, it's actually an error, it's a mistake essentially. So that's kind of why they use the phrase error. So it's a nice little bit of vocabulary issue there. But people call it the standard deviation of sample means or the standard error interchangeably. So either one is really correct, but you'll often see this phrase standard error when you're talking about an estimator.